Welcome to the second presentation into cluster building based on Vortex Mathematics. In first part we've explored the basic shapes that could be derived using our hexagon and hexagon plates. We've explored our octahedral and tetrahedral shapes, which today will go into a little bit deeper, as with Ian Armstrong's help we got more shapes 3D printed and I was able to explore the subject in a little bit more detail. So today we will explore more of the clusters and look a little bit more as well into the inner matrix that connects them together. Our basic shapes based on hexagons are in blue on this side, giving us golden mean proportions and ratios. In green we've got our regular hexagons with the inner grid 3D printed on the inside, and the white ones are our hexagon plates turned into tetra and octa arrangements. What we've explored in our first section is how compatible they are and how they connect one to another. Printing additional green full hexagonal walls allowed us to do a little bit extra rotations without the limitation of hexagons and hexagons. So I will go into this part when we start exploring our green matrix. So just to make a simple demonstration is they will work compatibly like this and with the rotation. The same applies here. So it's one on top of another and then rotated. I'll show you the grid and explain what changes when we rotate our shapes and how the inner grid would transform in each arrangement. So to go back to our first session, this was the most basic shapes that we can derive based on 5 tetra joined together. It's a mini pyramid which could be extended in size. This is our next size up, which we can again watch it in rotation. There is additional possibility in this cluster building where we twist the top tetra by using either different size windows or our regular hexagonal shapes. It gives, I believe, additional rotation of space and time. This one just lines up this way. We can also join 2 pyramids together and I'll do it in sections by placing one on top of another and adjusting our construction. Because it's got a very narrow window in the bottom, I will have to hold it to support it for you to have a look at. The next challenge we face is to have an inner matrix 3D printed on its own, but that will be probably our third part, which I hope to create maybe in the beginning of next year. We looked last time also briefly into connecting our tetras into this configuration. Because they are all joined with a double sticky tape, I thought that it was maybe the spacing that I did not address properly. We've assessed with the computer program that there is indeed a slight gap left between. So to create the sphere, which I believed is possible to build using 20 tetrads, Ian had to do minor adjustments. We ended up with this solid printout in two parts. That's why there is a join halfway through. But if I rotate it, it goes right through the center, and we've got two sets slightly twisted or rotated on each opposite end. Inside there is encapsulated platonic solid of icosahedron, and the latest discovery was that following in this fashion we can place our octa and surround tetra plates. Again, Ian will need to do proper adjustments to get this cluster to hold, but what appears in the center is this little solid. It's got 5 triangles on opposite ends and 5 squares holding it together, which after a little bit of help with connected as elongated pentagonal pyramid. What I have done with the pieces at the moment, they were unstitched, but if you place one of them, the sphere will fit into it from bottom and top. And also if you would add all remaining octa pieces, there will be a nesting space for them to fit all around. So that's something I will explore further. It will need some adjustments on a computer, and then we 3D print the models and see how geometry lines up using the grid of and matrix of interlocking. So this is another surprise that I'll put aside for a moment. And another little solid that unexpectedly popped out was from arrangements we also looked at before, where we've got 6 tetra in each cluster. There is a central space that's got this topography triangular pyramid, but if I lift it up, we're getting with triangular dipyramid. So there is another solid concealed within the matrix. If I place it back in the center and cover the top, if you look from the top, there is another opening here. If I place it in front of you, the same is happening on the other side. So what I believe is happening, and with matrix, if we expand it well enough, we can map up where our solids will be located. So it will be one in the center here, beginning of another one from this end, beginning from another one at the base of it, which could be on a side, give us a total new topography and of spatial orientation and relationship of the solid to itself. So this is the first part, when I'm just covering briefly once more our tetra possibilities. In next step, I'll bring some octahedral shapes, and we'll see what builds with this shape topography. This is our first cluster in our octahedral series. We have 1 in the center and 8 attached to its walls. So it creates a very neat and regular cluster with all the windows in the same size. With using regular windows, we can keep expanding it whichever direction we choose, and that is very favorable shape for truncated octa to work. Our next model was creating using our hexagene construction of octa. This arrangement to be sitting and connecting compatibly needs to have big and small windows interlocking with one another. I will spin it around and then move it in the air and rotate it in front of you so you can have a little bit of more in-depth look how different it is from different viewpoint, and how still compatibly we can see right through those windows that run through and interlock the whole construction into one grid. If you remember and watch the first YouTube, each window would have 5 points of radiating energy, so the grid is quite complex. The last sample in our octa interlocking possibilities is this one. I've used hexagon plates to create this cluster, but there is a rotation and the windows are facing one another, which leaves the gap which is unfilled by either tetra or octa, so it could be complete cluster on its own, or it may need totally new geometry to fill in the gaps to make it whole. But this is what happens when we use again 9 octa, but in a slightly different configuration to the first one. So just to show them side by side, we've got windows going into the center 1, 2, 3, 4, 5, and in this configuration we've got windows lined up 1, 2, 3, 4, 5. Our next possibility of arrangements are expressed in mixing octa and tetra together. This is the most basic fractal with octa in the center surrounded by 3 tetras. When we use 2 of them together and place one on top of another, one facing down, the other one up, we're creating a new crystal which has got its own grid also and its own connectivity. I will be exploring this connection in many formations, as when we build them up they will show us different applications and what really happens when we do join them like this. The first one is 2 sets when we this time connected 3 octa with 4 tetra, 1 in the center. I've created 4 templates of the same configuration. What we have in the center, it's the beginning of our vortex equilibrium in each one. With this geometry, we can achieve two outcomes. We can create cubo-octahedron or anti-cubo-octahedron, also called Johnson solid 27. So the way we achieve it is by placing one on top of another, and if I put tetra and octa, octa and tetra, interspersing right through, we are getting in the center our proper cubo-octahedron. And this is the fractality we will see that starts on the edges in different directions. What is quite obvious, even on a small scale, when we're creating cubo-octahedron, is there will be two triangles facing one another and two squares on opposite sides. To create our anti-cubo-octahedron or Johnson solid 27, we simply rotate the top part of it where our octa will meet with octa and tetra will meet with tetra. And inside of this configuration we have our anti-cubo-octahedron. Johnson 27 just doesn't roll nicely with this geometry, and I will explain a little bit further why. Cubo-octahedron and anti-cubo-octahedron are basically working together in space and time, independently or in combination with one another in layers. And we'll need to look furthermore into more clusters to discover how it works. This one I can add another step to it to show you the rotation that we can configure using this template. So if I place one on top of another, just lining up our geometry, we have to use octa-octa connection, octa-octa. So that's the beginning of our anti-cubo-octahedron in three directions. If I would swap the top here and continue joining octa, 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 then we've got our anti-cubo-octahedron spaced out all around and in first and second layer as well. If I swap it back to original position, it will be cubo-octahedron, anti-cubo-octahedron in the center, and cubo-octahedron which we can create in another layer at the bottom. So it is quite peculiar configuration. It's got two modes of expressing themselves independently, but it can also work together. To expand on this concept a little bit further, we need to move into bigger clusters yet again. So to keep expanding on our previous models, this is the next step. It was a little bit of a surprise as it originated from the very simple arrangement. That's what the central piece, if I removed the edges, would look like. So we're building here octa on top of octa, tetra on top of tetra, our anti-cubo-octahedrons. What is quite peculiar about this shape is the way it folds on the sides, and it almost looks like a round, circular configuration. But the pattern, if we ever look through, if we find two adjoining squares with two adjoining triangles, we know we're definitely dealing with anticubo-octahedron. This pattern extends further just by using what I started originally from. I just had to multiply the numbers and create 3 of them. So if I attach them to the corners, we're stretching it in space and time into triangular configuration, from the circular into triangular. This model could be built using our anticubo-octahedrons only, but there is possibility to finish it in a pyramidal form and changing it into a regular cubo-octahedron. The way this geometry holds itself together, this is just a sample that Ian has printed, but we've got 3 points coming out from tetra and 5 coming up of octa that do meet at a certain point. So if you would extend those lines, we're getting regular octa and regular tetra in the center, energetically interlocking the whole construction. This is just unfinished, but an indication for you how the pyramid could be built going up. We can also continue with our pyramid if we build the structure from the bottom. I'm lacking few more pieces, but it will have its apex at the top if we keep doing this configuration. So a little bit unfinished, but hopefully you can see what's happening here. With this type of building, there is another way of doing it. So I'll quickly undo the top and show you the relationship. If I build it differently, instead of putting our tetra on octa, I continue with octa on octa. I will change the configuration, because then our model will be more. I just want to get into the corners to show you the difference. We'll end up, instead of stepping it down like a pyramid, we've got another octa that will connect here. So we're basically building it up instead of into an apex. So it could be built this way, like a crystal, or it could be built into a pyramid. So that's 2 different configurations that are sitting on our base model, which started so innocently. I never thought it would grow in the way it did. And the last most surprising cluster was this one, which has octa in the center surrounded by tetra on 8 sides, and this is the most similar look to the Star of David in 3D. It gives us additional grid that connects this construction right through the center. What was quite interesting about this grid is that it assembles itself indefinitely and keeps true value of cubo-octahedron, so there is no anti-cubo-octahedron present in this cluster. It is purely cubo-octahedron in space and time, and we can see the beginning of each one. This cluster could be viewed from different angles. If we view it from the top, you will see you've got 3 octa that surround tetra in the center and 6 octas on the edges. If we rotate it this way, it's 4 and 4. So again, depending on the viewing angle, the cluster seems to be different, and yet it is the same. The next step that I will demonstrate is what happens. These gaps left between our octas, I will fill in with the tetra shapes, which will change dimension and the shape of it. So I've added few more tetra pieces to go all around in all the spaces that were left by our octa arrangements, and this is almost finished cluster that came out of it. As you can see, the dimensions have altered slightly, but by putting last remaining 3 octas at the top, I will be completing our cubo-octahedron here on each side. We have got them also from the other end as well. So I just quickly add the remaining pieces of the puzzle, and then I can pick it up and rotate it in space for you to have a little bit better understanding how this geometry lines up. So here we are, that's completed now, and as you can see, we've got this triangular pattern building up with our tetras at the top. So there is 6 octa, now 3 tetra. Joining it together, the same is happening on the sides, and each side is now looking like a triangle. But the symmetry of it is different to the ones we've explored before. If I turn it upside down, we've got the repeat what was at the top, again 3, 3, 3, connected by 6. So this was our beginning. Then we had octa, now we've got tetra. That's the final completion and transformation of this design, which is cubo-octahedron spaced in time indefinitely. In each opening gives us additional beginning of another formation, and that grid would look quite spectacular when we get it in line matrix. So this is the last cluster in connecting octa-tetra. To make one more point to illustrate how the clusters morph and transform from the original one, and in sequence, I had to undo one of the previous configurations to have enough pieces. But if we look at our original truncated octahedron, the next step was to surround it on 8 sides by our truncated tetrads and initiating the pattern of cubo-octahedron. The next step was to fill in those gaps with the second layer of our octas, and this is the cluster that we accomplished. By doing this, our cubo-octa is becoming fuller now. What we have on the sides is room to put additional tetras in. So the models, quickly spin it one more time, do morph and grow. And what's very, very interesting with this one is that we start from this shape. I was presenting it previously on the side. If we look at it from this position, we can see that this is extra large version, and I need to hold it, otherwise it's not strong enough to stand on its own. But we are expanding original shape with interlocking grid, creating cubo-octahedrons. So that's pretty neat design. So to conclude, what comes out of our clusters, here is again a little array that we've been exploring. Creation of anti-cubo-octahedron, tetra on tetra, octa on octa. That's cubo-octahedron in its first matrix. This is our spheres, which inside will contain icosahedron, and our elongated pentagonal pyramids, and our triangular dipyramids. So different solids that are hidden within the geometry. And with great gratitude towards Ian for his ongoing help and assistance to getting my ideas into life, we've started with this inner grid for our tetras and octas, and while waiting for our weather to be kind to us and have a sunny day, we have been delayed. So here are grids. Our octa with 4 tetras surrounding it. As I was explaining in the first YouTube, initially I was putting pipe cleaners through the windows and see how geometry would line up. Here is actual 3D printed model. So we've got our octa and tetras surrounding it, and the lines that do cross over keep it together on a triangular grid on each side. What I will do for you as well, very briefly, is also spin this configuration, because when we spin them, it's almost like a new geometry and topography opens up, and I do believe it is very valuable aspect of why this grid exists and why and how tetra and octa could coexist. So, okay, let's see if we unwind it now. So again, we've got circles. If we look from the top, we've got vortices going in, we've got vortices going out. It didn't spin fast enough maybe to see it, but the computer program will be able to show exactly what I mean. What's amazing when I look at it at night with a different light is how the octa in the center creates a vortices on its own, within its own grid. So it's got external but internal life as well. So this was our first model. That's another one which we started from tetra in the center surrounded by 4 octas, and that's how the grid is locked together. I'm trying to reach for a rubber band here because this one does its own spinning action, so very quickly. Okay, see. It modulates itself in another configuration, so each one will have a unique formula to it. But the way it dances in here, I guess, is very beautiful and elegant. Now, the very interesting grid came out of our tetra pyramids because we've got almost 2 grids interlocking with one another. Our windows do line up in space and time, and the grid is separate. The grid from one will be in the center of another, literally. So one pyramid is going down, and the other one up here, it's not exactly pyramid, but fills the space in between. So our points do line up. This geometry is very interesting. I spin it around a little bit. And it does have, I believe, a very important significance. Now moving along to one more model. This one I won't be spinning because it will not stay in the center. It would be this one, where we had our octas. This one was made out of hexagon plates. So here we've got again 2 grids. I left the joint to keep them together, but they do interlock in a similar fashion as our tetras. Spinning of this model, it's not very stable, and I think we're getting a bit too wobbly motion for it. But again, there will be number of circles. There will be circles generated by our inner grid, which is square at the moment. Then we've got another vortex and another, and one on the very edge, one from underneath here. So a very peculiar arrangements. So one more grid to look at would be one here. We've got our 3 octas on the edges. They were built in as one full solid models, and 4 tetras, 3 on the sides, 1 in the center. This grid looked unfinished, but it was just to make a point of 3 and 5 points connecting together. That's how actually they do connect. So this is another grid which we're able to derive, and this one is a little bit more stable, and it tends to go almost like a ball if you look at it from the bottom. I'll give it a couple of more spins, and let's see. So if you see from the side, it looks different from the bottom. Again, it's got a different profile. It's going a little bit slow now, but somehow this geometry likes to spin. That's just intuitive observation. And the last model, which is partly presented here, where we were joining our octa with octa and tetra to tetra. So we've got 2 sets of octas connected by 4 tetras. Again, where we were working with this grid, we ended up with the circle, we ended up with the big triangle, and again we were able to build it into the apex pyramid or like a crystal with straight walls. So with geometry, the more deeper we go, and it will reveal more secrets. As you can see, each cluster is definitely unique, not only in outer appearance, but also in inner one as well. We have discovered that our cubo-octahedrons and anti-cubo-octahedrons do work together in space and time through our cluster building configurations. However, there is another mode of them coexisting in space and time, and either by working independently, so cubo-octahedrons will work into cluster mode itself, or mixing cubo-octa and anti-cubo-octa together, or anti-cubo-octa on its own. There is a number of clusters that I derived from here. What seems to be important to notice is that if I called cubo-octa, our top triangle and bottom triangle are opposing one another. In anti-cubo-octa, they are in line from top and bottom. Also, two squares, two triangles. So we were able to put two cubo-octas in green and three anti-cubo-octas to lock this little cluster together. With this arrangement, we've got purely anti-cubo-octahedrons, so they look very similar. However, there is a difference here. If you follow where the triangles are, there is a rotation. It will show more when I expand the cluster into the next size up. However, I'm gonna go into four modes that can also be derived from connecting our cubo-octas, anti-cubo-octas in different formations. So, starting from 8 cubo-octas, 8 anti-cubo-octas, and this is combination of cubo-octa, anti-cubo-octa. So they all resemble a little bit truncated cubes. However, there is so much more happening here. If I place them on a side, and I'll have to move my central piece because it will be too unstable, I'll need to place them on a little triangle. But you will see how perspective does change and how we have different morphologies connecting the two together. What's peculiar about this one and every other cluster in this series is when we open it up, the center will be very much the same, which is two pyramidal shapes. So if I lift them up, that's what's on the inside in each one of those clusters. Another thing which will bring to mind that with this particular arrangement, if we look at it comparing top and bottom, they'll be always crossing 180 degrees, no matter which side I will look at. So there is crossover happening here. With pure anti-cubo-octa, we have this flower, so the energy is centering. This is into sides. This last one, mix of cuba, anti-cuba, octa, is different. We've got top and bottom, which this time would line up, but what is happening here, which I'd say it will be our midpoint, we've got two configurations either away from each other. If I keep twisting, now they will be facing one another. So that's another energetical grid that we can accomplish. Okay, so here we are with expanded models, mixing again our cuba octas and anti-cuba octas, or using them independently. So that's what's happening when we mix anti-cuba octas. We've got 3 in the center surrounded by 6 on the edges. Again, I have to put it on the table because they are a little bit too unstable, having to carry its weight on a narrow point. And this is our cuba octahedrons surrounded by anti-cuba octahedrons. So if you can see, we're starting to getting a spin and rotation. They start to line up in a different mode. In the last two models, I've rearranged things slightly again. I've got anti-cuba octa in the center connected to cuba octas on top and bottom, and again anti-cuba octa is locking it all together. And the last one, which had anti-cuba octas, one here, one there, and cuba octa in the center, so it's a reverse of this one. So we do have rotation. What's interesting, if you look at it from this perspective, that two of them, oops, I'm starting to fall apart a bit, will fold, if I swap them here to there, in a favorable way to add another cuba octas on each side, which I have done, and this is the slightly bigger version of what got created. So the models could grow. There is a number of possibilities to assemble them. There will be a definitely energetical difference, and I will get into it in a moment, showing you what I believe is hidden within cuba octa and anti-cuba octa on the energy grid level. There is an interesting aspect in this one. There is a center. I'll have to unpack it for you a little bit, so you'll see that. I'll take it away. As you can see, the inner center in this cluster was unfilled. I haven't had the time to do proper topography of it because those clusters were just done yesterday, as Ian keeps forever printing more and more pieces, as there is more and more to discover in this geometry. So that's another surprise. There was one more, which unfortunately we did check it on a computer program, and there is a slight minute degree that's missing to connect it perfectly. On the models like this, they do hold together, but the way it's assembled, it's got cuba octa ring at the top, anti-cuba octa and cuba octa ring at the bottom. So anti-cuba octa basically, it's locking it together. The difference that we're lacking to connect it tightly might be significant. It's hard to ascertain at the moment, but I will look into this possibility down the track and explore it further. And this is the last construction that I attempted in this series, and it would be 20 cubo-octahedrons. There is 5 more that needs to complete the top here. However, because of the degree missings, it's not gonna be a perfect sphere, just like with our tetrahedrons and the sphere I was attempting to build before. This one has got even smaller degree than the previous sphere, and I would like to have it 3D printed or have this model glued properly. It will still hold, and I do believe it is of value and has some sort of mathematical geometrical significance. What fits in into this arrangement would be our 5-sided pyramid, double-sided pyramid. So if I'll fit it in, you can have a look maybe from this side, but that's how the space is filled in this little cluster. So that was a lot of fun putting them together. You never know what you come up. It's a matter of just having enough pieces to start doing assembly work. What I was very fortunate with the few delays in the process of preparing this presentation was to get this topography, which was done at home, turned into our 3D printed models. We've got cubo-octahedron and anti-cubo-octahedron. This is maybe unconventional way, but that's the way I believe the pathways hold it as a grid together. If Star of David in yellow and in red, then we have our blue and then our purple matrix. Then we have our blue and then our purple matrix. So we've got 4 planes connecting the whole structure together. Each end has got 5 points radiating out, 2 of one color, 3 of adjoining one on each corner. What I believe is happening with anti-cubo-octahedron is this model where we've got Star of David in the very center, and the top and bottom, because the triangles lined up, would look like that. Testing it with pendulum, this one creates a vortex. Here I'm getting still point. I believe our purple lineup is responsible for this phenomenon. Let's have a look at the models 3D printed without our points coming off. This is our cubo-octahedron star, because that's probably most appropriate name to call it. I'm gonna spin it while I keep explaining a few more details about it. And I'm not sure if we get the right effect, but I've noticed that having models printed, an inside grid of it, if they are spun fast enough, they show how the energy interacts in the center. So we'll do experiment and see if it will show. If it's gonna be too faint, I might add it on later. So let's have a go.
Okay, so do it again. Just so I can do it again, and I'll do it from above. Okay. Okay, now talk.
Okay. So you can see we're getting the circles in the center, and we're getting very unusual vortices. The way I've looked at it at night with the light shining on, what's very obvious that if I place it towards you, this triangle, if I point the corners, is creating, because we've got it on few sides, a bell-like shape going down. The same bell-like shape formation, it's happening from the bottom and going up. And here in the middle section, we've got two vortices interacting together, so there is another wave forming. So it goes like this, and then a wave and down. But it's this vortex crossing over with this one, and this is an independent interconnecting it. So vortex equilibrium, it makes sense that that's the name that this has been derived, and I believe this is the proper grid for it. Looking down, we can see it also tends to go into the circles if we look at it from top, and also a waveforms, which is maybe a bit too hard to see. I hope to do animation programs in the future to demonstrate it properly, but let's have another go. So we've got inside ups, waves, we've got circles, and we've got external energy overlapping it as well. And this is a model of anti-Cuba octahedron, 3D printed. I've got few lines which I kept because the model is very fragile. I've got 3 points to hold it together. If we start working with both grids, it shows how easy they lined up. So if we connect triangle to triangles, the way we were working in those grids, here is our connection. If we go square to square, bring it closer to you, but the points will also meet. So we have got on a computer program this cluster created from inner grids just in Cuba octahedron, and it's a little beauty. So next YouTube part 3 will go deeper into inner grid of each Cuba octa and anti-Cuba octa presented in energy grid form. Discovered amazing world using our Cuba octa and anti-Cuba octa, as well as our tetrahedrons and octahedrons shapes. What seems to be quite obvious that we're getting tendency towards the pyramidal shapes whenever it will be triangular pyramid based on our tetras or even tetra-octa combination, or whenever it will be four-sided pyramid, which again resembles our octahedral eight-sided pieces. So geometry has got definitely phases, it morphs, the clusters do grow and do change topography. There is much more mystery in this whole subject than I ever thought there would be. So I will continue on a search and will explore it much further. I will look forward to our third presentation, where we'll look deeper into our interconnectivity in the clusters we were basing on our Cuba octa and anti-Cuba octas. Again, we'll be looking on inner grid matrices, not just the outer shells of it. I hope that I might be able to also achieve the program and show the internal spin and the proper pathways in each of the models that were presented here. So I would again like to say a great thank you to Darcy Robinson, who has been assisting for a number of years now in all the steps necessary that involve computer work to get this work out available to you. We do have a web page almost finished where the photographs were taken of each cluster from different angles. So if anyone wants to have a look at it, the link will be attached with our credits. Also great thank you to Ian Armstrong for doing all the 3D printing and creating computer grids, so we can check and double check whenever this geometry does work or not, how compatible the fields are. Also, my thank you to recording crew. This time it was Heather, Leo, and we've got James Robinson helping with this presentation now. So I look forward to our third part, and we'll see what the future brings and how this subject will unfold. Thank you very much for your time, and look forward again to your feedback.